What is simulation? I did any simulation. What is simulation? What is simulation? Huh? You did any simulation anywhere? Where? Oh, VLC you did simulation. Simulation means without doing experiment, find the result. Without doing experiment, finding the result is called simulation. How to find the result without doing experiment? Physical experiments you are not doing, but you want the result. That is called simulation. If you want to do the experiment without if you want the result without doing experiments, we need the mathematical equation. That is called a model of the system. If you know mathematically how to represent the system, then you can find the result mathematically. So mathematically find the result is called simulation, not computer. Using computer is not simulation. Inside computer, what we are using? Mathematical equations. So solving the mathematical equation is called simulation. Okay, anyhow, it is not important now. Here also, to find Kc and Ti, you need the mathematical model of this process. Finding that mathematical model of the process is called modeling. What is time constant? I think in transducer lab, you might have find the time constant of RTD. You find that RTD. You inject the RTD inside the boiling water. At what time it reaches 63.2% of final value? Time taken for that, and you will find the time constant. Am I correct or not? That experiment have you did? Oh. If time constant large mean, what is the meaning? Time constant large mean, what is the meaning? Time constant small means, what is the meaning? Why time constant is important? Why time constant is important? Time constant is large means it takes long time, slow device. Time constant is very small means it quickly reaches the final value. Small time constant. Have you understand this? So time constant is important. Suppose I'm having a process. You can take that RTD example. Room temperature is 30 degrees centigrade. The boiling water is at 100 degrees centigrade. If you inject the RTD into the boiling water, what will happen? Temperature will increase like this. Am I correct or not? It goes to 100 degrees centigrade. Time taken to 63. What is the time? This is the time constant of the RTD. This is the time constant of the RTD. X-axis is time. Another RTD, it goes like this. Which is faster? If you see the time constant of the blue one, it will be lesser. Another RTD, it goes like this. If you take the same 63.2%, how much? Larger. So if the device is slow, time constant is large. Where new car means small time constant. Old car means large time constant. That's why handling the car is very easy. So depends upon the time constant, these Kc and Ti we have to find. The formula for Kc equal to Tp, time constant of the process, divided by gain of the process, Kp, and dead time of the process, Td. We have to find these three parameters called modeling of the process. You are modeling in the transducer lab. You are modeling the RTD in the transducer lab. You are finding, you can write the model of the transducer equal to gain equal to 1 for all measurements, because for 100 degree it gives 100 degree. That's why K equal to 1. Ts plus 1. Like that you wrote the model. Am I correct or not? For RTD you wrote like this. This T only you found in the experiment. Am I correct or not? So this Tp is the time constant of this Levell process. This Kp is gain. If I open 50%, what is the level inside? If I open 100%, if I change the level, 5% valve opening is changed. What is the change in level? That is called Kp. Kp equal to change in level divided by change in valve opening. Change in level divided by change in valve opening. Valve opening, we won't talk in terms of 3 to 15 PSI, not in terms of 4 to 20 milliamp. We'll talk in terms of percentage. Suppose I am increasing 5% valve opening. Level also changes 5%. What is the gain? 5% divided by 5%. 1% per percent. Gain equal to 1% per percent. So if I open, level is changed 5%, valve opening is 5%, that is equal to 1% per percent. Therefore, gain of the process is 1% per percent. Suppose the level is changing 10%. Level is changing 10%. Valve is opened only 5%. What is the gain of the process? 2% per percent. If you change the valve opening some percentage, level also changes in terms of percent. Everything should be in percentage only. So that Kp you can find in terms of percentage. Tp you know how to find. Already you did the experiment in the lab. You know how to find. This Td only you do not know how to find it. The Td is dead time in the process. Some process, if you change the input, it won't change immediately. It takes some time to respond. For example, in the level process, I changed the valve opening. Say 5%. I changed the valve opening 5%. But there is no appreciable increase for some time. After that, it starts increasing. Then it settled at new value, say 10%. Earlier, it is 50%. Now it is changed to 60%. What is the change in level? 10%. But initially, there is no change in level. That part is called dead time. That is called dead time. New term, dead time of the process. Sometimes that may happen in some process. If you give some input, it won't change. It takes, after some time only it will respond. After some time only it responds. That is called dead time. What is the time constant? Time taken to reach 60%, 50 to 60, that is 10% change. 63.2% of 10%. 6.32. 6.32% to change 6.32%. What is the time taken? This only. This part is the TP, not total. After that time, what is the time taken to reach 63.2%? That is TP. What is Kp? Kp is for 10% change, how much you gave? Valve change. 5% opening. That 2% per percent is valve opening change. So you know Kp, you know Tp, you know Td. Now you can calculate Kp. Kp equal to, already I told you that for a PI controller, it is 0.9 times Tp divided by Td Kp. This is the formula. That's all. Thumb rule. 0.9 times Tp divided by Td Kp. Kp is gain, you know how to calculate. Tp is time constant, you know how to calculate. Dead time is, there is no response for some time. After changing the valve opening, you change it to 5%. But there is no appreciable increase in level. That is called dead time. If you calculate all these three, you can find Kp. Kc, controller gain. Kc equal to 0.9 times Tp divided by Td Kp. Kp is what? Here change is 10%. For how much change in valve? 5% change, that is equal to 2% per percent. That is Kp. Tp is say 5 seconds or 50 seconds. Td is 5 seconds. Therefore, Kc equal to 50 divided by 5 multiplied by 2. That's all. We can find Kp. Kc, controller gain. You can find Kc. We have to find Ti. Already one in the PID controller, Kc already we found. We have to find Ti. We have to find Ti. Integral time. That is called integral time. Ti equal to 3.33 times Td. That's all. Thumb rule. Now you know all parameters. This process is called tuning. Tuning the controller. Finding TP, TD, KP is called modeling. Because if you know all this, I can write the transfer function. G of S equal to, what is TP? TPS plus 1. I can write like this. Numerator, I have to put KP. Where I have to write TD? Dead time can be written like this. TDS. We have to write like this. This is the mathematical model of the process. That's why it is called modeling of the process. From the model, we are taking TP, KP, TD. If you put all these values, the tuning rule, you will get KC. TI also you can put T. If you substitute TD, you will get TI. That's all. Tuning is over. So we modeled, we tuned. Now we can control closed loop. How to do closed loop control? That what we have to do is, we'll come to the experiment now. I'll hereafter I explained all technical points so far. Now I will explain you how to do the experiment. How to do the experiment. You are provided with the Levell process. You are provided with the Levell process. There will be a TP transmitter. DPT is there. DPT is there. That will give 4 to 20 milliamps. 4 to 20 milliamps. This DPT is called two-wire transmitter. This DPT is called a two-wire transmitter. Two-wire transmitter means four-wire transmitter. Have you studied? Two-wire transmitter? Have you studied industrial instrumentation? Yes, but you didn't study that two-wire, four-wire transmitter. Any instrument, if asked, it has to work means what is required? It has to work. The DP transmitter has to work. For that, what is required? Huh? Power supply. Very good. You need power supply. 24-volt power supply is required. It will give 4 to 20 milliamps. So how many wires required? For 4 to 20 milliamps, 2 wire. For power supply, 2 wire. 4 wires required. That's why it is called 4-wire transmitter. But if you connect all these together in series, then it is called 2-wire transmitter. But whatever, in most of the industries, they will use only 2-wire transmitter, not 4-wire transmitter. They will connect DPT, plus terminal is connected here. DPT has negative terminal also. They will connect to 24-volt power supply. This is 24-volt power supply. This is negative terminal is connected to negative terminal. 24-volt power supply. This is 24-volt power supply. Here I want to drop this in how much? 250 ohm resistor. That is the load. That's all. The load, this is the experimental setup in the lab. 24-volt power supply, DP transmitter and 250 ohm all are connected in series. How many wires are used here? Only 2 wire. Power supply, load, this is load. This 420 milliamps has to be given at 250 ohm. Why? If you give across 250 ohm, for 20 milliampere, what is the drop across 250 ohm? 20 milliamps multiplied by 250, how much? 5 volt. You will get 5 volt. 4 milliamps multiplied by 250, how much? 1 volt. So it gives 1 volt means tank is empty. 5 volt means tank is full. That is given to the PID controller. PID controller receives 1 to 5 volt. Have you understand this? This is called 2-wire transmitter. 2-wire transmitter. Power supply, DPT and 250 ohm all are connected in series. All are connected in series. Have you understand this? 3 and 5. PID controllers, pin number 3 and 5, this 250 ohm is connected. Across 1, 2. PID controller works on 230 volt. Pin number 1 and 2, you will get 230 volt. That's why you don't think it is electronic instrument. The back panel you should not touch. That's why I'm telling this. You are giving how much? 230 volt power supply. Inside it is converted into 24 volt or 12 volt or 5 volt. I understand that. That's why back panel, how much power supply we are giving? 230 volt. It is open, not like electronics lab. Electronics lab எங்க வேணாலும் கை வைப்பீங்க. புரியுதா? நீங்க வந்து ஓபனா இருக்கும். You should be very careful. So 230 volt power supply, single phase 50 hertz power supply is given to that PID controller. Here we are giving 0 to 100% level. 0 to 100% level is given as input. PV is given here. That PID controller has pin number 3, 5. You are giving that process variable. Set point you can adjust inside. That display will come. You can adjust the set point. Set point is given as 50%. So the controller output is coming here. That is going to be given to I to P. Here it is giving 4 to 20 milliamps. This I to P will give 3 to 15 psi. For that I to P require 20 psi pressure. 20 psi. That is also given. 20 psi pressure signal is given. Here the DPT works under 24 volt power supply. That's why it is given. This is mechanical device. That's why it requires 20 psi. If you give 4 to 20 milliamps, it gives 3 to 15 psi. Power is 20 psi. Mechanical power is given. That 3 to 15 psi is connected to this valve. Connected to this valve. This valve 3 to 15 psi. This valve will adjust the flow rate here. That's why level will be maintained at 50%. How to do the experiment? This is the experimental setup, actual experimental setup. If I put, initially if I draw the same drawing, you cannot understand. That's why now I drawn the detailed experiment. From where the water is coming, this outflow rate is going to some sump. This is the experimental setup. How to do experiment, you will see now. The experiment consists of 3 parts. One is modeling. We have to find what and all? KP, TP, TD. That is called modeling. Second is tuning. You have to substitute these values in the formula. You will get tuning rule, tuning parameters. Third part is closed loop control. Always you want to control at 50%. Always you want to control at 50% or 35% or 30%. Depends wherever you will be asked to control, there you have to maintain the level. Let us assume that always I want to control at 50%. First bring the process to 50%. Suppose you want to drive the car at 60 kilometers per hour, means first thing what you will do, you bring the car to 60 kilometers per hour. Then only you can maintain. Maintenance only controller will do. Controller cannot bring to 50%. We have to bring to 50%. The controller will maintain at 50%. So now you bring the process to 50%. That's why what we have to do, in the bias we have to give. For that, we have to put the controller in 2 modes. One is called manual mode. Another one is called auto mode. You have to put the controller in manual mode. If you put the controller in manual mode, means it is not closed loop. It is called open loop. Open loop means, what is the controller output? M equal to what I wrote? Kc multiplied by error plus Kc by Ti integral of E dt plus bias. I said, this part will not work in manual mode. This part will not work. Automatically it calculates the controller output. That automatic controller output will not work. Then it is called manual mode. Then it is called manual mode. In manual mode, if you put M, manual mode, there are some, you can change from manual to auto, auto to manual. Initially, you put the controller in manual mode. First step I told. First step is take down. First step 1 is put the controller in manual mode. Other initial steps they will tell. You have to turn on the setup, you have to turn on the motor, those things they will tell. Put the controller in manual mode. Theoretically, I am speaking. Put the controller in manual mode. Adjust the controller output. Second step, adjust the controller output. Already I told you that you can adjust bias in manual mode. Say controller output equal to 50%. You are adjusting the controller output to there will be an increase decrease button. You see the diagram? There is an increase decrease button and one escape. Escape and enter. Enter key. Escape key. One increase decrease button. Only 4 buttons are there. In manual mode, if you put one more button is there, that is called an auto manual. If you put the controller in manual mode, you can increase decrease the controller output. You make controller output equal to 50%. You make controller output by increase decrease. You make controller output equal to 50%. Now the level starts increasing from 0. Increase. If the level increases, controller output also increases. Let us assume that this outflow rate is value is open to 50%. The level after sometimes take 20 minutes. After 20 minutes, the level comes to 50%. The outflow rate equal to inflow rate. Outflow rate equal to inflow rate. Say inflow rate is 5 liters per hour. Now outflow rate also equal to 5 liters per hour. What will happen to level? Level remains same. That's all. Now you are not using automatic mode, manual mode. Manually, you are adjusting the controller output to 50%. Level remains at 50%. Now, check whether the level is settled or not. Third point. Check whether the level is settled or not. When it will settle, if inflow rate equal to outflow rate, then only it will settle. How to find whether it is settled or not? There will be a display here. Display will be there. That display will display the PV. The PV will be displayed. Initially, it will be 0%. After some time, it becomes 50% display. PV will be displayed in red. Am I correct? Cross variable will be displayed in red. It varies from controller to control, manufacturer to manufacturer. In our controller, it will be red. That's all. PV will be displayed. Now, PV is settled at 50%. How to find whether it is settled or not? It comes from 0 to 50. The last digit only varies. 50.1, 49.9, 50.2, 49.9. Like that, it varies. It means it is settled. Then you made it 55%. 55%. Start recording the change in level in my notebook. So far, you didn't note any change. It is settled at 50%. Now you give 50 to 55. Start note down. Initially, it is at 50%. Then 50.4, 50.0, 50.0. 3-4 readings like that. After that, it starts increasing. 50.4, 50.9, 51, 52, 53. Like that, let us assume that it is settled at 60. It increases and settled at 60. How to find whether it is settled or not? The last digit only oscillates. It means settled. So now, first part almost over. First part almost over. The same way it did the experiment in transducer lab, finding time constant of RTD. You plot those values here. You subtract 50%, whatever the value available, plot this response. It will be looking like this. This is called a reaction curve. Reaction curve. You got reaction curve. You got reaction curve. You got reaction. It is between time and level. Percentage level. You subtract 50% from that, it varies from 0 to 10%. It varies from 0 to 10% because I subtracted 50. 50 is the nominal value. Note down new term. Nominal level is 50%. Now, always I want to maintain 50%. That's why that is called nominal level. So it varies from 0 to 10%. Find the dead time from the graph. Find the time constant, 63.2%. Time taken, this is called time constant. You got TP, you got TD, you got from the graph. KP you won't get from the graph, but KP equal to what? Change in level, 10%. What is the change in input? 5%. That's why 2% per percent you got. You got TD from the graph. Safe. 3 seconds. TP equal to 30 seconds. Just I'm writing some rough value. 3 seconds, 30 seconds, 2%. Therefore, I can find the tuning parameters. Kc equal to 30 divided by TP equal to 3 multiplied by 2. That's all. 10 divided by 2, that is equal to 5. 5 you will get. Kc equal to 5% per person. Because this is in seconds. This is also in seconds. These two getting cancelled. 2 is percent per percent. If you take inverse, then also it is percent per percent. Therefore, this is percent per percent. You got 5. Am I correct or not? 30 divided by 3, 10 divided by 2, 5. So you got Kc. What is TD, TP, Ti? Ti equal to 3.33 TD. That is equal to 3.33 multiplied by 3 equal to 10 seconds. You got. That's all. Tuning parameters I got.